Alright, so 1.6 is function operation and composition of functions. This should be review. You guys have seen this before. Yep, all of this. Okay, so I'm going to start with function operation. Okay, so the idea is that we are going to be taking two different functions. We are going to add, subtract, multiply, divide them, and then we'll also do some computations where we plug one into the other one. Okay? Alright, so first of all, sum. If I use sum in math, I'm doing what? What? I'm adding, right? Okay, so that notation can look one of two ways. You could see f plus g of x, and that would be exactly the same as if you saw f of x plus g of x. Okay, so that is just simply notation for difference. Okay, what's happening with difference? Subtracting. So that would be f minus g of x. Okay, that notation would be exactly the same as f of x minus g of x. Okay, what else could you do with two things? Multiply. What's the fancy word for multiply? When you multiply, it's called the product. Good. Product of two functions can be written as f times g of x, which can also be written as f of x times g of x. Okay, and the last one, what's the fancy word? Quotient. Okay, so to divide, you'd write f divided by g of x, which is exactly equivalent to f of x divided by g of x. So I'm going to do a couple examples. Okay, so I have written down three different functions. I have f of x, g of x, and h of x. Okay, let's do f plus g of x. Okay, so if I had those two functions, what would you do? Add them. So add what specifically?
Function.
Okay, so the functions are, okay, so f of x is 2x, or excuse me, x squared plus 4, and I would add that to the g of x, x plus 2. So would I leave it like that? No, I should probably combine my like terms. So I have x terms that I can combine, so how many x's? 5 x's?
2.
Plus 2. Okay, at that point, I am all done. Okay, it is a very common feeling to feel like you have to set that equal to 0 and solve it as an equation, but you are not solving an equation. Okay, you are simplifying a function. So don't do that. Just be done. Okay, let's do another one. Let's do subtraction. Let's do h of x minus g of x. Okay, so what would I subtract for these two? What's the h of x? And then I'm going to subtract x plus 2. Notice what I do when I do subtraction. Okay, so subtract that, tell me what you get. Ooh. Did everybody distribute the negative to the 2? Okay, in subtraction that is a very common mistake. Okay, be very careful when subtracting functions. You need to distribute the negative through that minus sign. Okay, we good there? Okay, let's do a multiplication. Let's do f times h of x. Okay, so what would I do for this one? What's my f? X squared plus 4x. What's my h? 3x minus 5. So if I multiply them, what am I going to have to do algebraically? FOIL. Good. Okay, so by FOIL, what is x squared times 3x? 3x cubed. What is x squared times negative 5? Minus 5x squared. Good. 4x times 3x? 12x squared. And 4x times negative 5? Negative 20x. Good. Okay, so I would combine any like terms that I can. I can combine some squared. So if I have negative 5 plus 12x squared, that makes 7x squared. Okay, and at that point, I'm all done. Okay, let's do the last one. Dividing. The dreaded dividing. Let's do g of x divided by h of x. Okay, so the g of x, hold on, let me make this smaller so I can see it. The g of x was x plus 2. What's the h of x? 3x minus 5. Okay, so now I have to simplify that. How to simplify that? Yeah, that's not simplifiable. That's done. That's simplified as is.
But how would you if it like?
Okay, so the only way you could actually simplify that is if you divided every term by some number. So like, for example, if every term had an x in it, you could divide everything by x. Or if everything was divisible by 2, all 4 pieces would have to be divisible by 2. Josiah, did you have a question? Oh, can you wait 10 minutes? Almost done. Okay. So dividing all those things the hardest is usually the easiest because there's not usually much more you can do to that. Okay. They will ask you something like this. Let's do, what is h of x, no, sorry, h of not x. Let's do 3. H of x plus, or h of 3 plus f of 3. Okay, so what would you do in this scenario where they actually replace the x value with a number? Okay, so sometimes it's easier to just do this kind of mentally. So if I go up to the original of h of x and I plug 3 into that, Okay, so I have 3 times 3 minus 5. What's 3 times 3 minus 5? 4. Everybody get a 4? So I could go 4 plus, and then if I plugged 3 into the F, let's see, that would be 9 plus 12. 9 plus 12, 21. So then I just add those two together, you get 25. Okay, so notice that if you are asked to put a number into the X, what kind of answer do you get out? A number answer, right? Okay, if they ask you in terms of X, your answer will be in terms of X. Okay. Everybody good with that? That's easy peasy. The second half of this is composition. Okay, so the notation that you generally see for this one is if you're dealing with an f and a g, f of g of x, okay, which is equivalent to, you guys remember the fog of x?
Yes.
Okay, so one of them is going into the other one. Which one is going into the other one? The G is going into the F. Very good. Okay, so the second one always goes into the first. Okay, so assuming we were given the f of x as x squared plus 1 and a g of x was x minus 4. What would the fog be? Fog of x. Well, you do that really fast. So which one goes into the other one? The G goes into the F. So for this, I'm going to take the G and I'm going to plug it into the X of that, right? Okay, so it would be x minus 4 squared plus 1. Okay, can I leave it like that? Okay, we should FOIL that out. Okay, so to FOIL it, I would have x minus 4 times x minus 4 plus 1. So it's x times x. What's x times negative 4? Negative 4 times x is negative 4x. Negative 4 times negative 4 is 16. So if we combine our like terms, we would get, bless you, x squared minus 8x plus 17. So what if I did a goth of x? You plug the f into the g, right? So now you would take the f and plug it into the g. So this one is a little simpler because now you would just have x squared plus 1 minus 4. Okay, so for that you would just combine your like terms and you get what? Minus 3, yeah. Okay, so what if they gave you, let's do a fog. How about a fog of 2? Okay, how would you do a fog of 2? Okay, good. So you plug 2 into the G. So let's do that mentally. If you plug 2 into the G, what's 2 minus 4? Negative 2. So then you're going to plug negative 2 into the F. So it's negative 2 squared plus 1. 5. Okay, so you see how those particular ones might not have work? Because you can kind of do those ones in your head. Alan likes those ones with no work. Okay, so here's kind of a brush off of this. What color should I go to? decomposition. Oh my gosh, I can't write. Okay, so a decomposition is kind of like undoing what you composed. Okay, so if our h of x is representing a fog, okay, so remember that the g went into the f, what potentially, and there's more than one answer to this, what potentially could the f of x be in the h or the g of x? So what could have gotten plugged in to the other function?
X will equal the square root of x, and g of x will equal x minus 4.
Okay, there you go. Okay, so you could have the g of x, the one that got plugged in, be x cubed minus 4, and the f of x could be the square root of x. See that? Okay, so the x cubed minus 4 got plugged into the other one. See that? Okay, what about this one? I'll give you one more, see if we can get this one. This one could be really hard, but I'm going to make it a little bit easier. Okay, so for that one, what could your g of x and f of x be? G of x could be x plus 5. So what would your f of x be? 2x squared. Perfect. Is everybody okay with that? Not too bad, right? So kind of the stuff that's in parentheses is the g, the one that gets plugged in, and then everything outside is the f. Okay. That should do it. So your assignment is on page 61, and let me double check what I have written down.
About 2 through 10. Sounds good with that.
Second.
2 through 10, you think so?
1 plus 4.
Yeah, I second that
2
motion.
through 10 even.
Sorry, guys.
2 through 20.
Evens. What?
No.
You got multiples of 4, right?
Oh no, I said evens on there. I'll take out the story problems, well at least most of them. I'll give you one story problem. I'll take them out this time. Okay, so that'll be due on Friday, beginning of class.